Questions 5 through 7 on the 2021 Grade 12 Euclid Math Contest. Chinara starts with the point 35 and applies the following three-step process, which we call P. Reflect the point in the x-axis, translate the resulting point 2 units upwards, reflect the resulting point in the y-axis. As she does this, the point 35 moves to 3, -5, then 3, -3, and then to -3, -3. Chinara then starts with a different point, S0. She applies the three-step process, P, to point S0 and then obtains the point S1. She then applies P to S1 to obtain the point S2. She applies P 4 more times, each time using the previous output of P to be the new input, and eventually obtains the point S6, which is -7, -1. What are the coordinates of the point S0? Well, S0, I have no clue, so I'll just call it XY. And let's see what happens when we start this process. So when you reflect something in the x-axis, it basically would result in the x-coordinate being the same, but the y-coordinate basically being the negative of what it was. And then when you go up 2 units, well, then you're just adding 2 units to the y-coordinate, so it's -y plus 2. And then when you reflect it, finally step 3, in the y-axis, the y-coordinate stays the same, but the x-coordinate becomes negative. It's a mirror reflection. So this is basically what happens in the first time you go through this process. Okay, so that's going to be the final result will be S1. So put the final result here. -y plus 2 like that. So let's go through this again. Again, when you do step 1, reflect the point in the x-axis. The x-coordinate stays the same, but the y-coordinate is like you're multiplying it by -1. So this will become 2 minus y. Or, sorry, it would be y minus 2. You're multiplying by -1. Okay, now you've got to raise it up by 2. So the x-coordinate doesn't change, but you've got to add 2. So if you add 2, it just becomes y. And then you're doing step 3, which is reflecting it in the y-axis. When you do that, the y-coordinate doesn't change the x-coordinate. You multiply by -1, so this becomes x, and that's just y. So it looks like I started right back here. So S2 is xy. And then when you go through this whole thing, it's going to be this again. -x minus y plus 2. So that's S3. -x minus y plus 2. And then when you go through this whole thing, it'll be xy. And that will be my S4. And then when you go through this whole thing again, as you can see, it just kind of keeps going back and forth between the same points. -x minus y plus 2. That will go to xy. And that basically is what x6 is. So they've given me x6. The S6, I should say. That's -7 minus 1. And they're saying, what is S0? Well, S0 is the same. So S0 is also -7 minus 1. In the diagram, ABDE is a rectangle and BCD is an equilateral triangle, and AD is parallel to BC. Also, AE is 2x for some real number x. Determine the length of AB in terms of x. Let's first draw a line from A to D. And when you do that, let's label this. So they told me that AE is 2x, so that means that this is also 2x, BD right here, because it's a rectangle. And then they've also told me that this is an equilateral triangle, so this is 2x and this is 2x, therefore. Okay, now they want the length of AB in terms of x, all right? Now, one very important point is this right here, that AD is parallel to BC. If AD is parallel to BC, we can use the Z pattern to figure out the angle. See, this is an equilateral triangle, so all of these are 60 degrees. And the z pattern basically says that that's the z. This would be the same as that in terms of the angle size. So that means that this is also 60. And since this is a rectangle, that's 90, and therefore that would be 30. So as always, in the 60, 30, 90 triangle, the ratio of the sides is 2, 1, and root 3. So that means that AB over 2x is the same as root 3 over 1. So AB is equal to 2 root 3x. Part 2, determine the positive integers r and s for which AC over AD is the square root of r over s. Okay, well, let's first figure out what is AD. AD, using the same triangle, that over, say, BD, would be the equivalent of 2 over 1. So AD would basically be 2 times BD, and BD is just 2x. So AD looks like it will be 4x. Okay, so now we've got to figure out AC. To get AC, first let's draw AC. A is all the way from there to there. And let's clean this up a bit. So AC is there. I'm going to draw another line, this time from C all the way to the other side like that. So that would allow me to figure this out. When you do draw that line, it cuts AE in half. So this would become X and this would become X. And then I want to figure out AC, right? So that's the red line. I think I can use Pythagoras or maybe another 30, 60, 90 situation. Well, let's see. Well, from the previous part of the question, we had figured out AB. It was 2 root 3x. So this from here to here would also be 2 root 3x. Like that. And then now I just have to figure out this part, and I'll be able to use those sides to figure out AC. Well, I know that this is basically the bisector of BD, and therefore this would be at a right angle. And this is 60 degrees since that's equilateral. So this angle would be 30. So again, we have a 30, 60, 90 triangle. This time this small one. So this side from here to here is X. So I can easily figure out that side. I'll just call it Y for now. So that means that X over Y would be, if you remember the ratios again, 2, 1, and root 3. So X over Y would be the equivalent of 1 over root 3. And therefore, cross multiply, and X times root 3 would be equal to Y. So there we go. We've got this triangle now. I can use Pythagoras. This squared is x squared. This whole thing is 2 root 3x plus y, but y is root 3x, so that's 3 root 3x. So plus 3 root 3x squared is my AC squared. So x squared plus 9 times 3, 27x squared is equal to AC squared. That's 28x squared is equal to AC squared. And therefore root 28x is equal to AC. Okay, so I've got everything to get this. AC over AD, therefore, is root 28x over 4x. So that's going to be, the x's cancel, root 28 over root 16, since I have to get it in that form. And if you really want to put it in that form, it would be 28 over 16. So that means my R is 28 and my S is 16. Now, one thing I wanted to talk about is they didn't say lowest terms. That I would have finished right there. But they might. I don't think they would, because if they really wanted it in lowest terms, they would have told you. But they're just saying determine positive integers for which this is true. And this is completely legitimate. It's totally accurate. But if they want it in lowest terms, you might as well, right? It doesn't hurt. Dividing top and bottom by 4. you would just get 7 over 4. And in that case, r would be 7 and s would be 4. Suppose that n greater than 5 and that the numbers t1 all the way to tn form an arithmetic sequence with n terms. If t3 is 5 and tn minus 2 is 95 and the sum of all n terms is 1,000, what is n? So we are told that we've got a whole bunch of terms here, t1, t2, and so on, right? t3, and then it goes all the way until tn. And it's an arithmetic sequence, so that means it's a plus d, a plus 2d, and so on, all the way until you get to the last one, which would be a plus n minus 1d. And we are also told that t3, the actual value is 5, and tn minus 2. So squeeze in a tn minus 2. That one is 95. So that one would basically be a plus n minus 2d. Like that. Okay. And then the last piece of information is that the sum of all of them is 1,000. So the sum of an arithmetic sequence is given by the formula Sn is equal to n over 2 times 2 times a plus n minus 1d. Okay, I think we have enough here. So let's work individually. The first one is a plus 2d is equal to 5. Okay, so that means a is equal to 5 minus 2d. Let's see if that helps us later on. The next piece of information is going to be, sorry, this should have been an n minus 3. Don't make that mistake. So the next piece of information, when corrected, is a plus n minus 3d is equal to 95. All right. So I can put that a is 5 minus 2d, and then n minus 3 times d. And let's see here. I think if I isolate for, if I already have a in terms of d, if I can get n in terms of d, that should help. Okay, so let's figure this out. We have 5 minus 2d minus nd plus nd minus 3d is 95. So that's going to be nd minus 5d is equal to 90. And therefore, I guess I could factor out the d, and that would give me n minus 5, and that's 90. So d is equal to 90 over n minus 5. Okay, that's very helpful. And then I guess I can plug that back into there to get a in terms of n as well. 5 minus 2 times d, which is 90 over n minus 5. All right, which is basically just 5 minus 180 over n minus 5. Okay, so let's plug it back into here. So that's going to be n over 2 times 2a. So that's going to be 10 minus 360 over n minus 5 plus n minus 1 times d. And d is 90 over n minus 5. Okay. I think I'll probably need a common denominator here. And Sn, they told me the total is 1,000. Okay, great. So let's multiply through by 1,000 by 2 to get rid of that fraction. So this is going to be 2,000 and then n. And then if I get a common denominator here, it'll be 10 times n minus 5. So 10n minus 50 minus 360 plus 90n minus 90. And that's all over n minus 5. Okay, so let's cross multiply that n minus 5. And then this is just going to be n times, let's see, collecting like terms, we're going to get 100n. And then minus 450 minus 50 minus 500. All right, so I think I can factor out 100. And when I do, I will get n minus 5. Okay, that means the n minus 5 cancels from both sides, so that's helpful. So all I'm left with is just 2,000 is equal to 100n. So therefore n would be 2,000 divided by 100, which is 20. And that's what they're asking for, the value for n. Suppose that a and r are real numbers. A geometric sequence with the first term a and the common ratio r has 4 terms. The sum of this geometric sequence is 6 plus 6 root 2. A second geometric sequence has the same first term a and the same common ratio r, but has 8 terms. The sum of this second geometric sequence is 30 plus 30 root 2. Determine all possible values for a. All right, so we have a sequence that is defined as geometric, so it's of this form: ar squared, ar cubed, and so on, right? So we are told it has 4 terms, so those are the 4 terms. And they're saying that when you add it all up, it has a sum of 6 plus 6 root 2. Okay, great. And then they're saying that you have another one, but it has 8 terms. So we're going another 4. So AR4, AR5, AR6, and AR7. And when you add those up, that sum they have given as 30 plus 30 root 2. All right. And then we have to figure out possible values for a. Had they given us anything else? No value for r. Okay. All right, so let's see what we can do with this. From the first one here, I think I can factor out an a. When I do, I get 1 plus r squared plus r to the power of 3. I don't know how helpful that is, but I just saw that. Or what I can do is just plug that there. So that's just 6 plus 6 root 2. Okay, and then just isolate for this here. AR fifth, AR sixth, AR seventh, like that. And then subtract that, so this is going to be 24 plus 24 root 2. Right? Okay, I think I can factor out a lot here. A and an r to the power of 4. So 1 plus r squared plus r to the power of 3. And then now I recognize something. This, let's see here. This and this combined is actually just this right here. So if I take out the r to the power of 4, I get just the a and this sum, and that is actually just the same as that, as you can see. So I'll put that there, 6 plus 6 root 2. And that is 24 plus 24 root 2, but I'm going to factor out a 4, because if I do, it'll be 6 plus 6 root 2. And then the 6 plus 6 root 2's cancel from both sides, and all you get is r to the power of 4 is 4. So that means that r squared is 2. It's plus or minus 2, but it can't be minus 2, right? Because r squared cannot be minus 2. R squared cannot be minus 2, because r squared is a positive number because it's a square. But this one will lead to r is equal to plus or minus root 2. So we got r, but we are asked to find a. All right, I think I can do that. Let's find my values for a. Now, first of all, which equation am I going to use here before I scroll up? I guess I'll just use this one right here. Yeah. Okay, I'll use that equation. So that means a is going to be 6 plus 6 root 2, all divided by 1 plus r squared plus r to the power of 3, like that. Okay. So first let's do it for r equals root 2, and then we'll do it for r equals negative root 2. When r is root 2, it's going to be 6 plus 6 root 2, and in the denominator 1 plus root 2 plus 2 plus 2 root 2. And that's going to be 6 plus 6 root 2 over 3 plus 3 root 2. And the numerator looks like it's 3 plus 3 root 2, but with the 2 out front if you factor it out. And then therefore it just cancels and you just get 2. So that's my first value for A. Now let's do it for r equals negative root 2. A would therefore be 6 plus 6 root 2 over 1 minus root 2 plus 2 minus 2 root 2. Right. So this is going to be 6 plus 6 root 2 over 3 minus 3 root 2. Okay, that is the answer, but we have to probably rationalize the denominator, and I'm never sure when they want you to do that, when they don't want you to do that. But just to be on the safe side, let's just do it. So multiply top and bottom by the conjugate of this, right? So that's going to be 18 plus 18 plus 18, 36 root 2 plus 3 times 6, 18. 18 times 2 is 36. And on the bottom, it'll be 9, and then the second and third terms cancel, and then you just get 9 times 2, which is 18. So that looks like 54 plus 36 root 2 over negative 9, and that looks like minus 6 minus 4 root 2. So that is the other value of A. Minus 6 minus 4 root 2 and 2. A bag contains 3 green balls, 4 red balls, and no other balls. Victor removes balls randomly from the bag, one at a time, and places them on a table. Each ball in the bag is equally likely to be chosen each time that he removes the ball. He stops removing balls when there are 2 balls of the same color on the table. What is the probability that when he stops, there is at least 1 red ball and at least 1 green ball on the table? Our scenarios are a green ball, and then a green ball, and then he stops because he has 2 of the same color. A red ball, and then he stops. Or we can have a green ball, and then a red ball, and then a red ball, and he would stop. Or a green ball, and then a red ball, and a green ball, and then he would stop. And similarly, you can start off with a red, and then get 2 G's. Or you can start off with a red and get a G and then a red. So either of these scenarios would result in stopping. But we are interested in what is the sum of the probabilities of those. So there's 2 ways of doing this, right? Figure out the probabilities of each of those and add them up. Or figure out the probabilities of these, add them up, and then subtract that from 1. So whichever way you want to do it is fine. First of all, how many balls are there? There's 3 green and there's 4 red. So let's figure this out. The probability of getting GG. Well, 3 over 7 is the probability of getting a green because there's 3 greens out of 7. But then once you pick 1 green, there's only 6 balls left and only 2 green left. So the next probability would be 2 over 6. And that is just 1 over 7. Now let's figure out that one. The probability of red and then red. The first red would be 4 out of 7. The second red would be 3 out of 6. And that, in lowest terms, is 2 out of 7. So when you add these up, it'll be 1 over 7 plus 2 over 7. And that is 3 over 7. So what you can do is you can say, well, the probability of these guys is 1 minus that 3 over 7. And that's 4 over 7. Or if you want to do it a way that's a little bit longer, you can figure out these individual probabilities in the exact same method, right? So for example, I'll just do one. GRR, probability of getting a G is 3 out of 7. And then probability of getting a red would be 4 out of 6. And then the probability of getting another red would be 3 out of 5. And that, in lowest terms, is 6 over 35. And in a very similar way, you can figure out the other probabilities. GRG is 4 over 35. RGG is 4 over 35. And RGR is 6 over 35. So if you were to add these guys, you would basically get, let's see here, 20 over 35, which is, in lowest terms, 4 over 7. So 4 over 7 is the answer, regardless of the way that you do it. Suppose that f at a is equal to 2a squared minus 3a plus 1 for all real numbers a, and g at b is equal to the log of b to the base a half for all b greater than 0. Determine all theta for which theta is less than or equal to 0, less than or equal to 2 pi, greater than or equal to 0, for which f at g at sine theta is equal to 0. Let's just talk about g at sine theta first. And that, according to this definition, would be the log of sine theta to the base 1/2. Okay, now let's talk about this f at g at sine theta equal to 0. Well, g at sine theta is that log of sine theta to the base 1/2, and that's going to equal 0. Well, just for the sake of simplicity, I'm going to let this log of sine theta to the base 1/2 equal a. And therefore, this just boils down to f at a equals 0. Well, f at a, they gave me. That's 2a squared minus 3a plus 1. And let that equal to 0. I think this factors very nicely. 2a, 1 and 1, negative, negative. Right. So that means a is either 1 or it's a half. So let's go back to here now. That means that log of sine theta to the base 1/2 is either 1 or the log of sine theta to the base 1/2 is equal to a half. From the first one, I get a half to the power of 1 is sine theta. And for the second one, I get a half to the power of a half is equal to sine theta. All right, I always like to draw a little graph, just a little sketch of the sine curve. This is 0, this is pi, this is 2 pi, like that. So sine of theta is a half. So in this range, I believe it's going to be here and here approximately. It's going to be a half twice, right? So that means if you do this on a calculator, you get 30 degrees for the first one. Therefore, the second one's got to be 150, 30 behind or before 180. And they probably want it in pi's. So this is pi by 6, and this is 5 pi by 6. All right, let's go to the next one. The next one is sine theta is 1/2 to the power of half. Well, that's just 1 over root 2. Very similarly, probably somewhere here and somewhere there. So using your calculator, and some of you already know this, it's 45 degrees, and then the other one is 135. So in terms of pi's, that would be pi over 4 and 3 pi over 4. So 4 values of pi for which that equation holds true.